The first thing is to recognize electrical symbols. So when we use electrical equipment in a circuit, we need to draw the circuit diagrams. So the circuit diagram consists of electrical symbols of different electrical quantities. So these are the most commonly used circuit symbols. The first one is a cell, which has a positive terminal and a negative terminal. And if more than one cells are attached together in series, it forms a battery. The third one is a lamp or a bulb. Fourth one is a resistor, a fixed resistor that is. Fifth one is an instrument that is used to measure the current in a circuit. So that is an ammeter. The next one is a voltmeter that is used to determine the voltage or the potential difference across a circuit. The next one is a switch, but it is a closed switch, and it represents the current can flow through this switch. And right next to it is a switch, but that is an open switch, and that indicates that no current can flow through this switch in this situation. Next thing is a LDR, or a light-dependent resistor, and as the name suggests, its resistance depends on the light that is falling on this resistor. As the intensity of the light increases, the resistance of this resistor decreases. The next one is a thermistor, again a variable resistor, where the resistance depends on temperature. Higher the temperature, smaller is the resistance again. The next one is a variable resistor, where the length of the wire is changed and hence the resistance is changed across this resistor. And the last one is a fuse that is used in series to the live wire. Now, basically we have two types of any electrical circuit. Any complex electrical circuit is made up of these two simple types of circuits, one being the series and the other one being the parallel. In a series circuit, you could see that there's just one path for the flow of current. So if the current flows from the positive terminal of the battery, the charges have just one path that it could flow through this lamp and then go back to the battery. In a parallel circuit, though, you have more than one path for the current to flow. So one path is through the first lamp, and the other path is through the second lamp. And if you have more branches, more lamps, or more electrical components here, we would have more branches for the current to flow as well. Then electric current. So basically, electric current is the flow of electrical charge, or the rate of flow of electric charge. So that charge actually comes from electrons. And how do we get electrons? We have to zoom in into the structure of a metal. So a metal is composed of atoms that are closely packed, and inside an atom we have its nucleus, and that nucleus has protons and neutrons, and electrons that are outside the nucleus, and they are moving in their orbits. And metals, because they have lesser number of electrons in their valence shell, so those electrons can be easily detached from their shells, and then we can have free electrons that could carry the charge and hence electric current. But to measure the electric current in a circuit, we need a device that is called an ammeter, as discussed earlier. But how do we connect an ammeter in a circuit? An ammeter is always connected in series with a circuit. So to connect an ammeter in series, we need to connect two wires to the ammeter, and both these wires are in series with the original circuit. So that means when a charge flows through this circuit, all of that charge must flow through the ammeter as well, so that the ammeter measures the correct value of current in the circuit. Since there is just one path for the flow of current, that means that in a series circuit, the current would be the same in all of the circuit. So if the current that is leaving the battery is 1 amperes, the same 1 amperes current flow through the ammeter A1 and ammeter A2 as well. But in a parallel circuit, you could see that there are more paths for the flow of current, more branches for the flow of current. So since 4 amps is leaving the battery, that 4 amp is then divided into 2 branches. A1 measures 2 amperes and A2 measures 2 amperes. But when they go through A3, both the currents combine once more, and hence 4 amps is measured by the A3. And that follows another important rule, that the current that leaves the battery must also be equal to the current that enters the battery or the cell. Different circuit here, where we have a parallel circuit, but within a parallel circuit, we have 2 lamps in the second branch that are in series. So that means if the current leaving the battery is now 3 amperes, now you could see in the first branch we have just 1 lamp. So 1 lamp means just 1 resistance that the electrons have to pass through. Whereas in the second branch you could see that we have more than 1 lamp, so 2 lamps. So that means we have more resistance in the second branch. So electrons always want to follow the path where they have lesser resistance. So more electrons would flow through A1 than through A2. So that means out of the 3 amperes, 2 amperes would flow through the first branch, and 1 ampere would flow through the second branch. So A1 would then read 2 amperes, and A2 would read 1 ampere. Okay, next up is, how do you define electric current? We've already defined it, that it is the rate of flow of charge, and that charge is carried in a circuit by electrons. So electrons are the charge carrier, and the equation is I equals Q over T. So we can solve these problems using the equation just quoted. So you could just pause this video for a second and try solving these 3 problems and see if you could get the correct answer. And if you get the correct answer, post that answer in the comment section. Okay, next up is a very important term in electrical symbols. That is a potential difference or voltage. And how does the potential difference voltage behave in a series and a parallel circuit? So to explain potential difference, we start with an analogy. Imagine this aeroplane that is flying over the runway. When this aeroplane is flying, it is actually at a height from the runway. So you'd remember from mechanical energy topic that if an object is at a height from the surface of the Earth, it has gravitational potential energy. So that means this aeroplane would have had gravitational potential energy. But as it descends downwards, its gravitational potential energy actually decreases. So the initial position at which the aeroplane was, it had a higher gravitational potential energy. So its initial gravitational potential energy was higher than the new or the final gravitational potential energy. So that means there's a difference in the gravitational potential energy that this aeroplane possesses. And the difference of that energy between these 2 points is termed as the potential difference. Now we could take this analogy to our electrical circuit, and we could say that potential difference basically tells us that a difference of the electrical potential energy at between any 2 points in an electrical circuit. So for example, in this circuit, if a charge moves from the negative terminal of the battery, let's say the EMF of the battery is, say, 1.5 volts. So that means that charge, that electron at this point has 1.5 volts of potential. Now, at any other point in the circuit though, say on the left side of this lamp, on the right side of the lamp, as the charge approaches the right side of the lamp, it has a potential of 1.5 volts, or it has an energy of 1.5 joules. So on the other side of the lamp though, since there's no electron on the left side of the lamp, that means there's no energy on the left side of the lamp, and that means there's no potential. So the potential on the other side of the lamp was 0. That caused the electron to cross the lamp, to pass through the lamp, because of that potential difference between the 2 points. And hence, when this electron moves through this lamp, it delivers its energy to the lamp, and hence the lamp lights up. So the difference in the energy between these 2 points, the potential difference, causes the energy of the electron to be dissipated across the lamp. So how do you measure the potential difference in the circuit? So the device that is used to measure the potential difference in the circuit is a voltmeter. And if you remember, the ammeter was connected in series in a circuit, but a voltmeter is connected in parallel in a circuit. So how do you connect a voltmeter in a parallel? So the two wires of the voltmeter are connected across the two ends of the lamp in this situation, but you could connect the voltmeter across any equipment like. So now let's have a look at how potential difference varies in a series circuit. So let's imagine a runner that is completing this 100-meter hurdle race. So when the runner reaches the first hurdle, the runner has some energy with which she is actually competing here. So the amount of energy was 100 joules. So to cross the first hurdle, she had to lose 20 joules of the energy, and 20 joules across the second one, and 20 joules across the third one. So that means across all of these hurdles, some of the energy of the runner was dissipated to overcome the obstacle. So you could take this analogy to an electrical circuit, that in an electrical circuit, potential difference actually describes the amount of energy that is dissipated across an electrical component. So if you have three lamps, three bulbs connected in series in a circuit, so think of the electrons as these runners and think of these lamps as these hurdles. So when an electron leaves a battery, it has some energy that it gained from the battery. But as the electron leaves the battery and reaches the first bulb, it has to give off some of its energy across the first hurdle, the first lamp, and then across the second, and then across the third lamp. So across all of these lamps, the electrons dissipate their energy as heat and light energy across the lamps. So potential difference actually measures the amount of energy that is dissipated. It accounts for the energy dissipated across these circuits by the electrons. So how does the potential difference then behave in circuits? So say this in this circuit, we have 1.5 volts, the potential difference of the EMF across the bulb, across the battery, the cell. So if we have just one lamp that is connected in parallel with this cell, the potential difference across this lamp would be equal to the potential difference across the cell. That is 1.5 volts. But if we have more than one lamps connected and same lamps connected, they have the same resistance, or they have the same rating, whatever you call it. So the potential difference across the two of these lamps would be divided. The potential difference, 1.5 volts, that was the potential difference across the cell, is then divided between these two lamps equally. So that means that at 0.75 volts. Now, changing the situation, we have two cells that are connected in series, and they both have 1.5 volts each. So the total voltage across the cells is now 3 volts. And then we have two lamps in series. So the total voltage that was 3 volts across the lamps is then divided amongst these two lamps equally, and hence both these lamps would have 1.5 volts each. Okay, now if you're given the potential difference across the lamps, you can calculate the EMF of the two cells, that is. So the total potential difference across the two lamps is 3 plus 3, that is 6 volts. So that means the total EMF of these two cells would be 6 volts. And in this situation, 9 volts across the two lamps, or 4.5 volts across the first one. So I think you can guess what's the voltage across the second one. That's 4.52. Okay, pause this video and see if you can find the answer to this question. And if you can, write your answer in the comment section. Okay, what about this one? 1.5 volts EMF of the cell, and then we have two lamps, two bulbs that are connected in parallel. Now, if these two lamps, both of them are in parallel, they both would get 1.5 volts from the cell. And since they get the same voltage from the battery, that means that they have the same brightness as. a new problem, and I'd again ask you to just pause this video for a second and see if you can find the missing numbers in this diagram as well across them. So in a series circuit, current is equal at any point, and the potential difference splits up over each component. Whereas in a parallel circuit, the current splits up down each branch, but the potential difference is equal across each of the branch. So that is just the two of the most important statements that we can make about current and potential difference in an electrical circuit. So that should be it for this video, but I'll continue with this topic in our next video. So don't forget to watch the next video on this topic as well. See you in that video.